In Lesson 9, we talk about ratio tables. Ratio tables are basically taking the equivalent ratios and writing them into a table. So let's take an aside here for a minute, and let's talk about equivalent ratios. So if I have a ratio of 3 to 5, to find an equivalent ratio, the first thing I want to do is I can write a ratio like a fraction. Since we already know how to find equivalent fractions, it becomes a little bit easier of a task. Now, if I want to find equivalent ratios, I can reduce. In this case, 3 over 5 cannot be reduced. So instead of dividing by something on top and bottom, I'm going to multiply by something on top and bottom. And 2 over 2 is the same as 1, so we're not changing the value of the ratio, we're just finding an equivalent expression. So 3 times 2 is 6, and 5 times 2 is 10. So I've just created a ratio, 6 to 10. And I can keep doing this. If I want to multiply 6 times 2, I can multiply 10 times 2. And I can get 12 over 20. And then I've just gotten a new ratio, 12 to 20. I can also just take 3 over 5 and multiply it by 3 over 3, and I would get 9 to 15. So there's another equivalent ratio. And we discovered that if we compute the value of a ratio, and the value of the ratio is the same, then we can determine that the ratios are equivalent. So let's take this and divide it. If I take 3 divided by 5, I should get 0.6, the decimal value of 3 divided by 5, or the decimal value of 3/5. And if I take 6 divided by 10, I should again get 0.6. That is the value of the ratio. And you'll find that if I take 12 divided by 20, I get 0.6. Again, same value. So since all of these have the same value, they're all equivalent to 3/5. They are all equivalent expressions. Now to make a ratio table, and going back to our problem, what we do is we first write the ratio. So I have x and y, which right now we're just going to know the left column is x, the right column is y, and we should always set up our tables like that. Eventually we're going to talk about graphing once we get to that point. At this point, we're just making a table. It says, for every 4 steps a child takes, his father takes 5. So that means the child's going to take 4 steps and the father is going to take 5. That gives a ratio of child steps to father steps as 4 to 5. If I find the value of the ratio, 4 divided by 5, I will get 0.8 or 8/10. And that means that for every ratio I put in the table, I would like to get the value of the 0.8. So the way we do this is we multiply by 2, then multiply by 3, then multiply by 4, then multiply by 5. So let's double our ratio. 4 times 2 is 8, and 5 times 2 is 10. So if I have 8 to 10, or 8 divided by 10, I should get 8/10, or again 0.8. The value is the same, therefore it's equivalent. Now if I do 4 times 3 and 5 times 3, I should get 12 to 15. Again, if you want to verify by typing into a calculator, 12 divided by 15 is 0.8. So since it has the same value, it's an equivalent ratio. Now I want to multiply by 4 for the 4th row of my chart. 4 times 4 is 16. 5 times 4 is 20. 16 to 20. And do these look familiar? just like finding an equivalent fraction. And for the last row, I'm going to multiply by 5. 4 times 5 is 20, and 5 times 5 is 25. And again, if I take 20 and divide it by 25, I should get 0.8. So on the homework, you're going to have a very similar problem. Set your chart up in the same way. It's going to have a few different numbers. But when it asks what can I say about the values of the ratio, the values of all the ratios are 0.8. And I can also say they are all equivalent.